Hi everyone, good evening. So today we are going to solve problem number 21. So what the data given here is in a pi attenuated network, the series arm admittances. The series arm means this is the series arm admittance YB and shunt arms. So shunt arm means YA as well as YC values are given. We need to find out Y parameters. So before finding, let's try to see the general procedure of finding Y11, Y12, Y21 and Y22. So here what I'm going to do is I'm going to redraw the given network and just I'm drawing only the impedance names as YA and YB as well as YC. So those who are following my continuous sequence of lecture, this is a very simple problem for them. And those who are new to the problem, just watch the problem and you can find the solution for this. So these are excited with voltage V1, and here I am assuming a current of I1 is flowing and the current in this branch is Ix, the current in this branch is Iy, and the current in this branch is I2, and I am assuming the current flowing in this branch is IA and the current in this branch is IB. So we are going to apply. So how to find out these Y parameters is, so here we are going to find out the Y parameters. Apply Kirchhoff's current law at node V1. Okay, so the voltage at this point is V1. Automatically the voltage at this point is V1. The voltage at this point is V2 and the voltage at this point is also V2. So apply KCL at node 1. So what are the entering currents? I1 is the entering current. The leaving currents are Ix and Iy. So how to write down Iy is, so I1 we can write down it as I1 is equal to Ix. So how to write down the current Ix, the current flowing in this branch is, so we have the formula current I is equal to V by R. We can write down this as Vy. So voltage into admittance. What is the voltage in this is V1 is the voltage and the admittance is Ya. How to write down the current which is flowing in these branches? High potential minus low potential. V1 minus V2 multiplied with the value of YB. So now this is, we'll get one equation relation here. So similarly, let's try to apply Kirchhoff's current law at node V2. So here there are three types of currents. How many currents are there? So entering currents is I2. The leaving currents are as per assumed direction as IA plus IB. So we no need to write down for I2. So just directly write down this I2. And how to write down the current IA, the current in this branch. It is V into Y. What is the voltage at this point is V2 and the admittance is YC. And how to write down the current IB in this branch. So this is nothing but high potential minus low potential. This is V2 minus V1 multiplied with the admittance of YB. Now let's try to segregate in the standard format. So you may get what is this standard format. Standard format is I1, I2 are the dependent variables. We are going to get Y11, Y12, Y21 as well as Y22 in terms of V1 and V2. Therefore, the ultimate equations are I1 is equal to Y11 V1 plus Y12 V2 is one equation. Second equation is I2 is equal to Y21 V1 plus Y22 V2. Now compare with this equation. So we require this format. Okay, I can write down I1 is equal to v1 ya plus v1 yb minus v2 yb. Second equation is I2 is equal to v2 yc plus v2 yb minus v1 yb. So first we'll take v1 as common term. So I1 is equal to v1 into ya plus yb minus v2 into yb, and I2 is equal to minus v1 yb, and take v2 as common. When you take v2 as common, this is yb plus yc. So now when you compare with the standard equations, I1 is equal to y11 v1 plus y12 v2. I2 is equal to y21 v1 plus y22 v2. So when you compare, the expressions of y11 is this value, and this is the value of y12. So this is the value of y21. This is the value of y22. So when you write down in the standard format, so then we can write down it as y11 is equal to ya plus yb, whereas y12 is equal to minus yb, y21 is equal to minus yb, as well as y22 is equal to yb plus yc. So these are the values you have been got. So now in the given question, we are already having the values of ya and yb. Okay. So when you substitute here, the value of ya, yb, yc is given. The value of ya is, this is 0.1 into 10 to the power minus 3 plus minus 0.05 into 10 to the power minus 3 at an angle of minus 90. So this is minus yb. Yb value is minus of minus 0.05 into 10 to the power minus 3 at an angle of minus 90. So this is minus of minus 0.05 into 10 to the power minus 3 at an angle of minus 90. So this will be plus, minus into minus is plus, and here yb plus yc is minus 0.05 into 10 to the power minus 3 at an angle of 90 plus 0.2 plus 10 to the power minus 3 at an angle of 90. So here these are in polar form. We have to perform the polar multiplication. Okay, so actually polar we can directly do it only when they are in multiplication and division, but these are in we have to use our calculator to find these values. Okay, so after solving you are going to get the resultant values are, so when you use your calculators and convert, this is 1 into 10 to the power minus 4 minus I into 5 into 10 to the power minus 5. So this value will be j 0. Use the calculator, then automatically we can find out. So these are the resultant values as what is asked in the problem as y11, y12, y21 as well as y22. Hope you have understood the problem in a detailed fashion. If you feel the video is useful to you, please give one like, please share with your friends, and if you have any doubts, let me know in the comment section, and subscribe to the channel, which is like a motivation to us, which will help us to do more videos for the benefit of the students. Yours obediently, Ram. And moreover, this is a free channel for the betterment of students and faculty. So this will help you a lot to learn. Thank you for watching. We'll meet in the next video.